Hey again, we find ourselves at the forefront of yet another series. Well, I don't know about the forefront, but we find ourselves at yet another series type, and that's very cool. In this video, we're going to go over telescoping series. Now, telescoping series, these are one of those rare series types of which we can actually evaluate the sum. So I'm going to often remind you that you usually will not be able to find the true sum of a series, but if it's a telescoping series, you often can. So let me show you what a telescoping series is, but just kind of tell you this little mini warning. This is not on the BC exam, although a lot of professors and BC teachers do ask you to understand this. So let's jump into it. So this says find the sum of this series. The best way to do this is actually by expanding it out and checking out what our terms do to each other. It's very, very, very cool. Notice that you have 1 over n minus 1 over a number that is 2 more than this. So this fraction will always be greater than that one since you have a denominator that is smaller than that denominator. The smaller the denominator, the larger the fraction value, right? If you have the same numerator values. Without any further ado, let's expand this. So if I plug in 1, I get 1 over 1 minus 1 over 1 plus 2, which would be minus 1/3. And I like to put these in parentheses. You'll see why in a second. I add on then my second term. Now I'm going to plug in n equals 2. 1/2 minus 1 over 2 plus 2 is 1/4. All right, seems pretty innocuous so far. Plus, now I'm going to plug in 3. N equals 3. 1 over 3 minus 1 over 5, right? 3 plus 2. Plus, we'll do one more, and I think that'll be enough. N equals 4. 1/4 minus 1/6. And it keeps on going. And what I'm now going to do is stretch it out, and we're going to go out to the nth term and see what we get there. Or maybe the n minus 1th term, you'll see. So 1 over, and we're plugging in the n minus 1st term. That's one term less than the nth term, wherever that is. Minus, if I plug in n minus 1, that's n minus 1 plus 2. That'd be n plus 1. Plus, and then I'm going to plug in the nth value here. That would be 1 over n minus just 1 over n plus 2. And then it keeps on going and going and going. Now, what you're going to see here is that this term right here, and I guess I'll circle it, this term right here, and that term right there will never be subtracted from. We're never going to get a 1 from the 1 over n plus 2 because this started out at 1/3 and it's just getting smaller from there. However, do you see how the negative 1/3 and the positive 1/3, 2 terms later cancel? And the minus 1/4 right here, and the plus 1/4 cancel 2 terms later? So that's going to keep happening because this thing is 2 terms greater. It's going to take 2 terms for that first fraction to cancel out 2 terms down the road with the second one. Isn't that cool? So minus 1/5 will cancel in this next term here, and minus 1/6. And then on the other end of things, 1 over n minus 1 will have canceled with the 1 over n minus 1 that this thing would have taken on 2 terms ago. Same with 1 over n and the minus 1 over n that came 1 term ago, before this one. So what we're left with is a telescope. The reason why it's called telescoping is it expands out, and then we contract it down when we see our subtraction. So here's what we're left with. This series is equal to then 1 plus 1/2. Everything else cancels, and then we're left with the n plus first term plus, or I should say minus 1 over the n plus second term, and then it just keeps on going on and on like that technically. But here's the important part. This is your sum. Right? That's going to be our nth term of our sum, for sure. So if I take the limit as n goes to infinity, and you remember how we did that with our partial sums? It's the same thing here. We take the limit as n goes to infinity of s sub n. 1 plus 1/2 minus 1 over n plus 1 minus 1 over n plus 2. So each of these terms are constants. They remain in a limit. And this is 1 over infinity minus 1 over infinity. Each of these will go to 0. So we end up with 1 plus 1/2 minus 0 minus 0. And that simplifies down to 3/2. And therefore, that is what this series converges to. So the series converges, but we're really not even asked to justify that. It's just show what it converges to. Isn't that cool? So a telescoping series, in general, when you want the infinite sum, you take the first uncanceled terms, right? And that's however many terms that this number is off by on this one is however many you'll get. So this is 2 less than this, you'll get the first 2 terms. If this was 5 less than this, it'd be the first 5 terms, and so on. So you take those uncanceled terms and you subtract the last uncanceled terms. So that'll be the last two uncanceled terms, because if it's the first two uncanceled, then it's going to be the last two uncanceled. It balances out like that. And then you take the limit as n goes to infinity, like we showed there, and we got our answer. It's not that bad. So when do you use this? If you have a factorable denominator or the difference of two fractions, it's a strong likelihood that you'll be using the telescoping series. Again, it's not on the BC exam, but that would be the situation where you would use it, and you'd likely be asked for the sum of the series. So it doesn't take long to expand it out and then contract it to see if it does telescope, to see if terms cancel out. Worth a try. Okay, so let's do one more. This is find the sum of this. Notice this has a factorable denominator, so we can rewrite this by, well, basically seeing that it's a separable equation, right? We're going to do partial fractions here. So 1 over n minus 2 and 1 over n plus 2, we've got those two values, is equal to a over n minus 2 plus b over n plus 2. And now we get to work here. We're going to multiply both sides by n minus 2 times n plus 2. And if you're having trouble with this concept, please go back to chapter 8 where I go over that in the middle to early part of the chapter. 1 equals a times n plus 2, multiply both sides by the denominator, plus b times n minus 2. And now what we're going to do is let n equal to, let's just cancel out the b term, n equal to 2. We'll get 1 equals 4a. 2 plus 2 is 4. A is equal to 1/4. Nice. And then we'll do b, n equals negative 2. So we're going to get 1 equals b times negative 4, negative 2 minus 2. So b is equal to negative 1/4. So what does all this mean? Well, what it means is we can rewrite this series as n equals 3 to infinity of 1/4 all over n minus 2 minus 1/4 all over n plus 2. Now the thing about a series is, if you've got a constant, we can factor it out, just like we could in an integral, or just like we could in a limit or in a derivative. So I'm going to factor out a 1/4 out of all this stuff. So let me take out the 1/4. Now that we have that all in there, this will each become 1, and this will be 1/4. All right, so all we're going to do now is expand out the series. So I'm going to kind of box this up nice and tidy, and let's keep rocking and rolling. So I'm going to take the limit as well. Let's not take the limit yet. Let's just add it up. Let's expand it. So I got 1/4. The first term, well, they're 4 terms apart, right? Minus 2 and plus 2 are 4 terms off. So the first 4 terms are going to be canceling. So I've got 1 over 3 minus 2 is 1 minus 1/5. And then that'll be plus. The next term will be 4 minus 2, which will be 1/2 minus 1/6. Plugging in 4. Plus, and then you'll start to see the pattern. 1/3 minus 1/7 plus 1/4 minus 1/8. And notice nothing's canceled yet. 1/4 still hasn't met the 1/5. It'll happen here. Plus 1/5 minus 1/9. Plus, and then we'll go dot, 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 plus. Now, here's the thing. You know that the last 4 terms are going to be what does not cancel, right? It would be n minus 1, n plus 1, and n plus 2, technically. I'm okay if you just realize that a lot of things are going to be canceling out here. For instance, the 1's going to be staying, the 1/2's going to stay, the 1/3's going to stay, and the 1/4, because the highest fraction this will ever be is 3 plus 2, or 1/5. So if we notice that, the minus 1/5 and the plus 1/5 cancel. The minus 1/6 will cancel out with the 1/6 that's there. The minus 1/7 with the 1/7, the minus 1/8, and so on and so forth. And then eventually we'll get down and we'll have 1 over n plus 2. And a whole bunch of other terms remaining. The point is they're all going to go to 0, right? So I've got the limit as n goes to infinity of 1/4 times 1 plus 1/2 plus 1/3 plus 1/4, all that did not get eliminated, right? And then we'll do that, and I'll just write it as minus 1 over n plus 2. There's a few other terms in there. They're all going to 0. So if your teacher needs it there formally, make sure to follow what your teacher wants. Point being is, all of this is going to 0 right here, right? Because it's over infinity. So that's going to 0. You'll be left with 1/4 times. This will be, let's see, 3/2. This right here, well, that is going to be 4/12, and 3/12 is 7/12. This is 18 twelfths, and 7 twelfths is 25 twelfths. Ugh. Which is equal to 25 48ths. And that is what this series converges to. Again, this went to 0. We just need to see what the terms are that don't eliminate. And again, the number of terms that this is off by 4, are the number of terms that will be left, and technically the number of terms that will be left on the other end too, but I just wrote the 1 over n plus 2. All right, we'll leave it at that. That's telescoping series. Go like this, and then contract it down. You'll remember it. I know you will. See you next time. Exercises for this lesson